So the time is 14:45. Time for the next presentation, and I will leave the word to Jonas Wenner and Gabriel Neves, who's going to talk about Quadri and Tekla Structures. Jonas and Gabriel, welcome.
Thank you. Thank you.
Thank you.
So the title of this presentation is Quadri Tekla Structures, Data Flow from Road to Bridge Design. So let's travel from the roads through the bridges and see what Jonas and I have to show you. Our table of contents, introductions, the workflow, and then some takeaways. Hopefully we still have time for some Q&A.
Yes, so then me, Jonas, today I'm gonna play the role as the road designer and also a little bit the role of the surveying and geospatial guy here who creates some background material as well for the road designer. And normally I work in Gothenburg, Sweden for Trimble with the civil design software systems here.
And I'm Gabriel Neves. You know me from this morning. I'm going to play the role of the bridge modeling and all the structures. And I work for Trimble for 7 years to help with bridge-related stuff. And together, we're going to play the role of commandant environment. So all of us, we have a role within the commandant environment, taking things out and putting things in. If you think this workflow, and I want to highlight here the arrows, right? So should be Tekla sending stuff to the surveyor directly? Probably not, all right? So I said it in this morning, take this with a pinch of salt because probably we should go through follow the procedure. The data goes to the commandant environment and then from there goes to the surveyor or to the construction. So but this is just to show that we can exchange data with all these players. And of course, commandant environment can send data through the construction site directly, so without going to the surveyor. And then when we go and have our playground, the road designer can be using NovaPoint or any other vendor solution to design the roads. The surveyor can use Trimble Business Center and again, any other solutions. On site, they have all this hardware from Trimble. And then for commandant environment, we have the object-based agnostic platform Quadri, and we have Trimble Connect file-based and now object-to based platform commandant environment. For modeling, we have Tekla Structures. I start bringing with me SketchUp. Maybe later next year, I'll have some news and incorporating Trimble SketchUp with Tekla Structures. Jonas, I will move the slides, all right?
Yeah.
Okay.
Do that. You can move to the next as well there and start the film. So this is the basic of everything, of course, in a project that you need to have control of the existing situation. So in this case, we have a terrain model that we have imported from some kind of source. In this case, I believe it's the Brazilian Land Survey Agency, the governmental agency there. And then there is a river here where we didn't have so much data for the riverbed. So we have sent out some surveyors in a boat with some equipment to make a profile of the bottom of the river where the bridge should be. And then we can merge this data together inside Quadri as a terrain model. And then we just bring all this together in an existing situation model inside Quadri. And this existing situation, then we use that as a base for the construction of the road, and also then we can send it into Tekla with the Tekla connector to have as a base for the bridge design as well, for example. And as you see here, we can add some nice textures inside Quadri. We can add an orthophoto. We can model existing pipes, existing buildings. Yeah, whatever data you have access to, you can bring it into Quadri and use it in this existing situation model, really. I think that you could just go to the next, Gabriel, as we
Okay.
saved some seconds.
Right. Yes.
Yeah.
Road data to Tekla Structures. So here now I am in Tekla Structures. I am just importing the attributes for the coordinate reference system into Tekla Structures model. Because the surveyor gave me the KML file with the site control points, I use that as my project base point. And so now you just probably remembering this from this morning presentation. And I just go to Quadri because I have access to Quadri. I'm not dependent on Jonas. I know how to create my task and I know what I need to place inside that task in order to do my bridge, right? So I'm not touching their work at all. I just place the information I need to do my job. With the Quadri connector, the task is reserved in Quadri and I put information into the correct construction phases. So I want my model clean, and then even later, if I need to update that information and replace the road lines, for instance, I know which phase I should turn on and just check and replace all that. So this is what I'm doing here. Project base point is important, and import the Quadri features. So now I'm ready to do my bridge. Let's see if the video shows bringing some more data. For instance, if I'm doing an underpass and if I have the slopes, for instance, and I was doing that many, many years ago. And in the past, we would do cross sections and just to define the wing walls. And from the moment we have 3D data, we just place the wing walls just looking at it and moving up and down or opening the angle of the wall. So that is why the slopes are important. So here just giving a clean, and we have here kind of the depth of the river. So in this view, I have the river, and let's go now to modeling the structures. So to modeling the structures, and because this video is, this presentation is more for you all to see a little bit of both worlds. So it's not about Bridge Creator, it's not about Grasshopper or technique of modeling bridges, but just highlighting here something. I'm reusing this road data, and I've changed, or Jonas changed the center line name, which never happens. I guarantee that never happens. But here, because I had the bridge on a different model, I wanted to reuse, not to do a new bridge, and I just need to change the center line because I had my file saved, and I read the road lines again, and then I replace the center line. So Bridge Creator is connected with the road, extruding the objects, and some of the objects, the top follows the road, the bottom is flat, because if we put a virtual point with a Z, then we can constrain the soffit of the objects to that virtual point. That means the object is horizontal in the bottom. Just to remind you if you don't know about that. So here just the opening. So all these cross sections, they can be as complex as you want, including the longitudinal parabolical variation and just loading files here. So the bridge it's done just for some time, just placing that. While this is loading, I'm just going to highlight the fact of that parapet was a bunch of blocks. So the job was the existing stones, they need to be reused. So and then I use Bridge Creator to place every single block, so in this case a component, into the correct place. So here just trying to fight with the snapping of the, just to do here some, put the foundation into the correct place, 2 meters below the level. Many times from Quadri we bring the bedrock, so that will be even easier. But here just pretending, okay, we need to go 2 meters below. and then just use the direct modification, just move on, just to illustrate a bit of our work at bridges. That is never so simple as the video is showing. So you have seen, if you were at session 1, you have seen this one too. But I want to highlight here that there is a Tekla component that the wall varies based on tables, depending on the depth of the height of the wall. All the dimensions they change, and this is a real example from DOT, Department of Transportation in USA. So is their typical wall, and I know I can control now the width of the wall or how depth the depth of the wall below the final ground level, but is a Tekla component. Here simulating another user that is doing an underpass. I'm so sorry about those foundations. I guess the designers there will send this back, but this is just then to get here. So live collaboration. I really hope you are testing this out. So we can have on the bottom Trimble Connect, maybe a designer that is not having access to Tekla. And then on the top, we have 2 Tekla users, each one with one model. When they all enter into the same session, they see the models of each other. So it's temporarily, the models are going to be there. And then they can have the interdisciplinary meeting, and we're going to see here that the first user placed the walls. So the second user shouldn't have wing walls on that underpass, right? So he could, in live during the meeting, just delete it, right? So that is exactly what he's doing. And just remember to change all the view type to perspective, because then you can follow or force following one of the users, and see everyone now is following the Tekla user number 1, right? That is giving instructions that, hey, delete that wall, right? And when he deletes, the other models they update, and these models are there while you are inside the session. And funny enough, even after leaving the session, the one user could go and bring the session again, and the stuff is still there. Okay, stopped in time, but it's still there, right? So here, the first user is going to delete the wall, but then I just remember I cannot do that. I placed the wall with the grasshopper, so I need to time to do it. I need to check the stations for the start, and that's it. It was just a teaser about that. Now sending structures to Quadri. So bridge is finished. I created a bridge Bianco task that is empty. I like to have the stuff clean. And then eventually, when the bridge is inside that bridge Bianco task that is empty, it needs to follow some conversion rules, the naming, the materials, and so on. And I like that, because then I can have lots of objects that they don't follow the standards. That means they are not going to pass to Quadri. So if we want our objects in Quadri, like you're going to see now, they need to follow those conversion rules. So it's very important. So everything inside Quadri then will be within the standards. It's quite cool. And then, of course, this task with the bridge can be inside another tasks, and Jonas is going to show that, because he's going to use the bridge, but mainly what he's doing is putting this task with the bridge inside whatever tasks he is working on. So just selecting the objects, I can select the attributes I want, or even UDAs, and send the data to Quadri. And now here the conversion rules are going to appear, and you'll see pile, abutment, deck, pier, whatever name convention you have, Tekla objects, they need to have that name, and then the objects will pass. So this is just a visualization just to see that. And now I'm happy. They can now check the interaction of the bridge with maybe drainage or some whatever is there near the river, right? I could do that too. We could do that with Connect, but since Quadri is the single source of truth here, we're going to do it and using Quadri. Editing road design, Jonas.
Yeah, so what we didn't show you first now was the basic road design that we did Before Gabriel started modeling the bridge, but now he is modeling the bridge and the underpass. And what I do here in the road design software is that I use his models, and then with some simple means we create just an sort of alignment on top of this underpass, for example. And then the road modeling software we use here, NovaPoint Road, it's a parametric software, so we can just add this alignment we have created that is then the top of the underpass of the wing walls there. So we just say to the model that between these two stations we wanted this model to have a boundary on top of that wing wall, and then we just recalculate the road again. And this means that we will just trim the road model against these concrete walls, which makes it that we will have the right volumes and the right stakeout data and the right surfaces created by the road software again. So this is a really good example of this integration between two different softwares, really, that we use first the preliminary road design to send that into Tekla, model the bridge based on that road or the road alignment and the road model, so to speak. And then we take it back and we update the road because of some kind of stuff that we need to do with the road, and then we get this working together quite fine.
And Jonas, it looks like I messed up one of the wing walls, so I needed to change that and update the model again.
Yeah,
and
I
then
think
you'll
so.
see it. You'll see it. Yeah. Or
Yeah,
you could let me know that. Yeah.
Exactly.
Do a comment
Yeah.
to do. Okay.
So that's
modeling embankments.
So it's all about this workflow, really, that you work together. It's not that you send the road data one time in the project to the bridge designer. You are sharing the data all the time, and it's an integrated workflow.
Right.
And then, yeah, the next here, an example is that modeling those embankments that we call them, and that's also that what we do here is that directly in Quadri, or of course extracted in some ways from the bridge designer, I can just extract some 3D lines from the bridge, and then I bring them into my CAD platform where I have functionality connected to NovaPoint. And in this case, we just create these embankments at the end of the bridge, and this will also have an automatic volume calculation. How much fill is it here? And it's also possible to create much more advanced stuff like this if we use, for example, my road design software. But this is a really simple one to get the slopes, the fill slopes for the bridge there. And then, of course, in all projects, and I suppose especially in Brazil, where this project is located, it's raining a lot, so we need drainage. So, and that's also something we can use NovaPoint to make this drainage designs. And you also, yeah. So what we do is that we use the software that is called NovaPoint Water and Sewer, where we define a typical section of the trench, for example, for the pipes. And in this case, we are working in 2D in our CAD platform. We have open in parallel, but everything we do is automatically created as a 3D model of this water and sewer network or drainage network. And you can model almost everything that is connected to pipes with this tool. You can connect electrical cabling, conduits, drainage, water pipes, and also combine trenches with a lot of pipes in the same, and the software will always create a 3D model of it with calculated volumes, calculated numbers and length of all the pipes included, and so on. And you will also have all the stakeout data needed for the construction of this trench. So all is integrated here in it. And you also see here now when we just make some calculation of the trench, and then we just wait for it to be stored back into the Quadri model. And there we can just drag it onto our view, and then we see our our manholes there with the drainage pipes and so on. And of course, we could send this also as reference data to the Tekla model to use it as in data for the bridge design as well there. So it works more or less in the same way as when you use the road as in data to Tekla. You can also use the trench for some ways. And then the last thing about when we use this, when we use the Quadri model in together with Tekla, is that we can also use this cut and fill calculations for the support pillars of the bridge. So here we just see that we have this longitudinal profile at the bottom through the bridge, and there you see the excavations and fills for the pillars of the bridge, for the columns. And we can make this with the same functionality as we used for the fills at the end of the bridge. So in this case, we just create 3D polylines as well at the soles here, and then we can add this. We can say to the system that it should offset these lines 1 meter from the line and place it 1 meter below, for example, to make the excavation pit a little bit larger and deeper than the sole of the bridge, for example. So I do this here both for the retaining wall, and we do it for the columns of the bridge as well. And you see also that it creates this 3D model of the excavation, which we can then export from Quadri as stakeout data, for example, to the machinery on site when we should make this construction.
Jonas, would you send this, of course, first to Quadri and then from Quadri to TBC or to site?
Yeah,
Right.
yeah. You can send it to TBC and make more with it there maybe, but you can also send it directly to the site from Quadri as well. You can export, but it depends, of course, on the surveying guys who need to receive this data. If they want to make some extra work on their own, it could be transformations, it could be whatever, remodeling in some ways. But in this case, it's quite easy to get control of the volumes as well, because inside Quadri here, I can just create now a volume calculation with all these cut and fill surfaces and compare that to the terrain model, and also if we have a rock model or something at the bottom here to see how much rock cut and soil cut we will get out of this. And we can both see these calculated volumes as solid objects, and we can also make a really simple table to see how much cut and fill we have in this model for the bridge. You see that, so it creates objects also of the calculated volumes here. So it's a separate object each one. You see this is cut objects with a certain volume connected to it.
Right. The takeaways of this today's presentation is that we really believe at Trimble that we have great solutions and we go from design to site. So yeah, I think it's a fact, and we have all those machines on site. Again, we know that you are very successful doing your job, right? So the only thing that today we are highlighting is that if you never looked into your colleague that's using NovaPoint or Quadri and so on, just pay attention, look at them. And the same, if you are using NovaPoint and Quadri, look at us, Tekla, and then remember there are connectors to bring and send data. So mainly that is today's takeaway. So take advantage of those connectors to exchange the data between our solutions and even competitor solutions. Any questions? I don't know if we have or not. So we launched two polls. So one was to do with which products you are using, and then which ones do you have access, right? Because maybe you are not using Quadri because for some reason you don't have access to it, and you should, or you can, right? So I'll be very curious then to check those results. Let's see if Frederick can help
Yes, and I have one question. I have two questions, and we still have a couple of minutes to go. I will read the question here. Do you need to have license for both programs, or can you, as a Tekla user, collaborate with Quadri user that makes the design tasks for you?
There, the answer is both yes and no, but it's if you as a Tekla user should be able to directly communicate with the Quadri model as Gabriel did here in this in the demo, then you need also a license on the Quadri system as well. But I know a lot of examples from customers who uses the connector that there could be a whole team that works with Tekla, and there is one of the bridge designer who has access to Quadri and make all the sending and receiving of reference data and sending the model in. So there is different ways of doing it.
Yeah, the last thing I wanted was to have 10 or 15 people accessing Quadri and sending bits of the bridge to Quadri, right? So yeah, maybe one person is responsible to do that exchange of data. Good idea.
I take the next question. What was the AutoCAD app to do the cut and fill?
Yeah, that was one function inside NovaPoint in our design tools in NovaPoint. So NovaPoint works on top of both a CAD platform and on top of Quadri. So it's like a hybrid environment. So and that actual function to make the cut and fill, that is that's available both in the road software, in the water and sewer design software, and also in the landscaping software. So it depends on, but everybody who works for Ramble, you have access to NovaPoints. It's just to install and get license there, Augustine. So no problem.
Go for it. We still have 3 minutes to go. Can the NovaPoint work on top of Rhino?
No, it cannot. It works on top of some of either AutoCAD or Trimble Drawing. It's the two CAD platforms it's compatible with.